Hello, in this lesson I'm going to solve the problems I have left for you in my previous videos, right, about the second law of thermodynamics and the video about entropy. Okay, so the first problem I left to you was this one. And that's related to the second law of thermodynamics, right? We have this tank here, insulated tank. Half of the tank was filled with gas and the other half was evacuated. Then we open the valve here in a way that this gas expands and fills the entire volume. Okay? We want to demonstrate that this process is irreversible using the Kelvin-Planck statement. Okay, so that's the situation. You have the tank here with this part filled with gas and this one is evacuated. We open the valve and now the gas is everywhere. It fills the entire tank. Okay, so let's analyze this situation first. So for this situation here, we can use the first law of thermodynamics. So the variation in the internal energy is the heat transfer minus the work. Well, the tank is insulated, we have no heat transfer, we have nothing attached here, so the work is also zero. So this variation in internal energy is actually zero, so the final internal energy is the same as the initial internal energy. Right, now let's do something here to this system to try to demonstrate that the first process here, the gas passing through this valve, is irreversible. Let's attach a turbine. So we want to try to create a cycle here in order to produce some work, right? So, well, in order to the gas to expand in the turbine, we need to do this first process where the gas goes from this half to this half in order to expand in the turbine, right? Then the second process would be this expansion, producing energy. And the third process actually is heating the gas on this half here in order for it to move to this other half, okay? Well, here we have some problems, right? The first one is that the cycle draws energy from a single reservoir by heat transfer and produce an equivalent amount of work. And this, if you remember the statements for the second law of thermodynamics, we cannot have this cycle producing energy with just one thermal reservoir, all right? And well, this process, number one, actually is impossible, right? Remember that the final and initial internal energy are actually the same. So this process does not occur naturally, okay? And if it's impossible, well, it's also irreversible, right? It will not happen. There's no way we can heat the gas here in order to expand in the cycle to produce work, all right? It's impossible. This process here from the gas going from this part to this one is irreversible. It does not occur naturally the other way. Okay, that's the second problem we have that's related to the entropy video. So for this problem, we had a hot rock that was ejected from a volcano's lava fountain, and it was cooling down from 1100 degrees Celsius to 40 degrees Celsius, and the entropy decreased by 950 joules per Kelvin. We had done our calculations and found that the heat transfer is actually negative, around -8 times 10 to the 5th joules, alright? And we had a problem here. That was the question I asked you. So how does this entropy decreases, right, without violating the second law of thermodynamics? So this process occurs, right, naturally. we have a hot rock, and, well, the temperature decreases. So we have a negative heat transfer. And, well, we're actually decreasing the amount of entropy. So what happens? How can it decreases? If the second law always says that it states that the entropy, the net amount of entropy, has to increase. It's always more than zero for a real process, right? And I gave you a tip to what happens to the entropy of its surroundings. That's exactly the answer. Okay? So we have our rock that's hot, okay? But then it starts decreasing its temperature. So we have some heat transferred from the rock to the environment. And that's the tricky part where most of the students get wrong, okay? Our system is actually the rock plus the environment. The rock needs to transfer heat to somewhere, right? And this is the environment. So actually we have that the entropy of the rock is decreasing, but the entropy of its surroundings, the environment, is increasing. And this entropy here is actually greater than this one. The increase here is greater because we would need we would need to add some work here in order to put all this heat back into the rock. Okay, so the reverse process does not happen naturally, right? So it's irreversible. It's a real process. So we have that the net entropy, variation of entropy, is actually positive. It's greater than zero. So it does not violate the second law of thermodynamics. Okay? Always think about the system, the entire system. So we have the state of the rock, the entropy, yes, it's decreasing in the rock, but in the environment is increasing. All right? So these are the answers. Hope you enjoyed, and see you next time.
What did you think about this video? We appreciate your feedback, so tell us in the comments section.